Alright, here's a geometry question. The square below has a perimeter of 32 units. If arc DFB has a center at point C and arc BED has a center at point A, then find the sum of the areas of region 1 and 4. Alright, well, what do we see here? We know it's a square, and we know the square has a perimeter. That means the distance all around. So we can figure out what each side is. That could be helpful. So that's where we're going to start. So if the square's perimeter is 32, how many sides does it have? 4. So 32 divided by 4 gives us 8 for each of the sides. So the first thing I'm going to do is just fill in an 8, an 8, an 8 all the way around there. Now take a look at that diagonal there. See that diagonal for DB, line segment DB? That's cutting the square in half. So if I find the area of the square, because look at our question, the question's wanting to know area. So the area of the square is just length times width or side times side. So 8 times 8 gives me 64. And then I know it's half of that for half of the square. So that would be 32. Okay, why would I want to know that? Well, they want us to break it down into regions. So region 1, region 2, region 3, region 4, we need the areas of 1 and 4. Do you see a bigger figure going on here with that arc? See how that arc has a center of C, it says? It says arc DFB has a center of C. So this is arc DFB. So it has a center at C. Can you not picture that that would be a circle going all the way around? And how much of that circle are we seeing? Well, if we were to extend that out, that would be half of the circle if it extended out to here. So really this is just cut into a fourth. So that arc region represents a fourth of the circle. I'm going to shade that in so you can see it. That's a fourth of the circle's area. So my area of the circle is pi r squared. I'm going to plug in an 8 for the radius because I know the center is C, so that means that represents the radius there from the center to the edge of the circle. So that would be 8 squared, which is 64, and then 1/4 of 64 times pi is what I'm looking at. So a fourth of 64 just divided by 4. And we get the area is 16 pi for our quarter circle. So in other words, regions 2, 3, and 4 have an area of 16 pi. I'm going to label that. So 2, 3, and 4. In my half square, what does that represent? What regions? 3 and 4. If I was looking at from DB at this triangle, that's half of the square. So 3 and 4 represents that of 32. Any ideas now? We know our region's areas. So see how this one has 3 and 4, that one has 2, 3, and 4. So what if I just took the big arc and subtracted out the square from it? What would that leave me with? Well, that would leave me with region 2. So, and that's what I'm going to do. I'm going to do 16 pi, which is my my quarter circle, and I'm going to subtract out the triangle there, and that just leaves this region 2. That's the only thing that's left when I subtract. So I'm going to do minus 32. I used my calculator and I got about 18.3 there. So that's the area of region 2. And wouldn't you agree that region 2 is identical to region 3? Yeah, so 18.3 is also going to be my area for region 3. And now look at what you know. You know about region 3 and 4 is 32. You know the area of region 3 is 18.3. So how can you just find the region of area 4? Because that's what the question wants. That's right, we would subtract. So we would take our 32, the region 3 and 4, this triangle, subtract out the region 3, that arc portion, and that'll give us the area of region 4. So that's what I'm going to do next. And that gives me 13.7 for the area of region 4. So if I know that's 13.7, I know which one is also exactly like region 4. Region 1. So all I need to do with those two numbers is double them. So 13.7 plus 13.7, and we are left with 27.4. Alright, so 27.4. Okay, remember the key though is just to see that that's going to be a larger circle, and that portion right there represents a quarter of a circle. That was the key to this problem, and then knowing that if they gave us the center, that distance is the radius. So just picture it if you ever have part of a diagram, think if you extended it out what it would be and what you already know. So we just used our area formula, pi r squared, we took a quarter of it. Then we did the same thing for the square, because we know if we cut a square in half, then that's the area of half the square for the triangle. Alright? And then finally we subtracted smaller regions from larger ones, and that was really the key in solving this problem. So if you know region 1 and 2, and you know region 1, then if you subtract them out, you can find the other region. Alright, hope you learned something.